In this video, I'm going to review the questions you were given on your Chapter 12 practice quiz in order to help you prepare for the actual quiz on this. And so for question number 1, you're given this information that you randomly select 49 of 496 sophomores, 34 of 348 juniors, and 48 of 481 seniors were selected from a local college for a study. So there was some grouping going on here, which means that, we're looking at between these two. I can see arguments made for either of them, but most of the time when you're dealing with a cluster is that you tend to take all the elements of the cluster. I mean, so I would tend to choose all the sophomores, all the juniors, all the seniors. So that's kind of one thing that kind of leads me away from that one. Also, along with that, it also would depend on, if, the group of freshmen were just automatically excluded or not chosen for this. If that was the case, and I had four groups, but I only chose members from 3 of them, then I'd go more towards a cluster. Since that would require us to read into the problem more than what's being stated, the fact that I have 3 groups here and I have members from all 3 groups being chosen, it's more heavily leaning towards the stratified sample for this. So that would be the best answer for the situation given. As I said, those two get really, difficult to discern from time to time, especially since, since they're very close to, in many different ways. For the next one, sample consists of every 49th student that from a group of 496 students. The fact that you said consists of every 49th student, this one, that kind of terminology gives it away automatically. It's systematic. Because, I count the 49, that's the person I choose. If I count another 49, that's the person I choose, so forth and so on along the line. The next one. The pollster uses a computer to generate 500 random numbers. Then interviews the voters corresponding to those numbers. Since they were given, there was 500 people, 500 number, or people were given all people were given numbers. 500 numbers were randomly chosen, and those are the people chosen. This is a random sampling. And always be careful, just because the word random appears in it doesn't necessarily make it random. I can randomly choose every, well, not so much every 49th person, but I can randomly choose like people from clusters. I could randomly choose which clusters I choose for a test. So there's some randomness there, but, primarily it might be a cluster or stratified. So, just because you see the word random does not mean it's automatically a random sample. So be careful about that. The next one. A researcher interviews 19 work colleagues who work in his building. So basically he just kind of grabbed whoever was around, if that's a convenience sampling. And that's usually the worst type of sampling that you want to do. And the last one, an education researcher randomly selects 48 middle schools, interviews all of the teachers at those schools. So basically, they were grouped according to being in middle school. So so middle schools were the groupings. So this middle school, that middle school, the other middle school. And then everybody from the 48 that were chosen were sent. So you see, you get randomly 48 middle schools, but we know there's more than 48 middle schools, across the state, across the country, whatever the case may be. So we know it's not purely random. This one here is more of a cluster, because all the teacher population is what we were looking at, and all teachers from each cluster that was chosen were used. So again, some people could probably argue stratified. If there was only 48 middle schools, say, in a particular region, and they randomly but the fact that all the teachers are chosen, that would make it cluster. If I would select a certain number from each group, that would, there'd be some argument for being stratified. So, if you have trouble between knowing if it's stratified or cluster, give an explanation along with it if you can, or, or send along with me or something like that, or if it's on paper, and try to explain it as best as you can if you're given the opportunity, because the two are very closely related to each other. For the next one, question 6. In 2008, the federal budget showed a large surplus. The Pew Research Center asked 2 questions of random samples of people. Give me a second here. There you go. These questions were as follows. 1, should the federal government cut taxes or use revenue generated from those taxes to fund the first-time home buyer incentive? Should the federal government fund the first-time home buyer incentive, which allows working individuals to earn a refund of $8,000 for purchasing a house for the first time? One of the questions drew 58% favoring the first-time homeowner incentive, while the other only drew 34% in favor of that program. Which wording pulls respondents towards favoring the program and why? So you had, statement 1 and statement 2. Generally, because the second one explains that, you have working individuals, purchasing a house for the first time, the American dream type thing. This one's probably the one that got the 58% in favor of it because it shows that it's helping working families, and things like that. Whereas with no information whatsoever, it's just, in some people's mind, just something else that, our tax money is being spent on that doesn't, help, the common person, So that's the way it probably would go because of the fact that, and sometimes, a loaded question, some people would say that the second one's a loaded question, but sometimes some people can say that the first one's loaded. Because sometimes loading a question sometimes means, not providing information about what you're asking for. If you ask like, are you for or against, Article 431? And, you don't know what it is. Okay. Do you want to spend tax money according to the legislation in Article 431? Well, as soon as people say spend tax money, no, keep my taxes down. Meanwhile, if you find out it's like to help homeless kids, find places to live and be housed and stuff like that, then they might be more in favor of it. So sometimes loading a question can mean not providing information as to what it is. So that people just, respond one way or another based off of, other things they see in the question. So that's what this one kind of gets at. So definitely the second one would be more expected to draw the 58% favoring the first-time home buyer incentive than the second one would, or the first one would. Question 7, and I'm not writing a whole bunch of statements on for this. I'm just kind of stating them here. A researcher wished to gauge public opinion on gun control. He randomly selected 1,000 people from amongst registered voters and asked the following questions. So far, setting up a good sample here. Randomly selected people from registered voters. So these are people that would tend to vote on such measures about gun control. Do you believe that gun control laws which restrict the ability of Americans to protect their families should be eliminated? So what's the abuse of statistics here? Well, this thing here is saying that the gun control law, stating what the gun control laws do, which is argumentative. I mean, if you look at both sides of the story, some believe that's the case. Other ones believe that, that we're just restricting certain firearms and, do you need to have a bazooka to protect your family? Do you need to have something that could tear through a house, or destroy a house in your house to protect your family? I mean, so so this one's here is stating an opinion about what the gun control laws do, and someone's opinion might be different. So if you're stating an opinion as part of the question, that doesn't help. I mean, so if they wanted to state that do you believe that the gun control laws, which restrict these sorts of weapons, that would be fine because you're explaining what kind of weapons are being restricted. It's being more definitive on that. But if you're stating that in that opinion that it's going to take away people's ability to protect themselves, that's going to cause bad feelings. So obviously it's a loaded question. the way it's been stated, and it's definitely going to pull people away from, stating they believe in gun control, the gun control laws, even if they do make some degree of sense. So, question 8 kind of gets a little beyond stuff that we talked about. It's this type of thing that sometimes is explained to people. A company accused of downsizing workers defended itself with the following statement. Yes, we were forced to lay off 25% of our workers last year, but this year we increased our workforce by 32%. I said it's 25% of our work. Okay. And we therefore have a larger number of employees than before the layoffs. What is the flaw in that argument? Because some people would believe that. So, well, we got rid of 25%, but they replaced it with 32%. What's the flaw? Well, let's take, for instance, um, last year. Now, I don't know how many employees are here, but just to pick a number, say there were 100 employees. Well, if we laid off 25%, that means that we would have 75% left after the layoffs. So we'll say layoff here. 75% left, or since it was out of 100, 75. Now, I don't know how many people were actually there, but that means if there was 100 people working there now, we would have 75. This year, we're starting with 75 employees. And now we hire. So there's 32% more now. So the thing is, it's not going to be 32% off of the 100 we had last year. It's a 32% increase from what we have now. So I would take that 75 plus 32% of 75, which would give me 75 plus 24, which gives me 99 employees, which is not what we started with last year. So some people see those percentages, they think, well, I got a higher percentage this year, so it went up and it made more than made up for what I lost. Well, no, not in this case. It was close, and it would be much more of a concern if these were in thousands, because instead of being off by 1, you'd be off by 10, or if you had 10,000 workers, you'd be off by 100. Those numbers start to be different. So the fact that hiring 32% this year did not replace all the workers that we got rid of last year means that we still have a smaller workforce than what we started with the previous year. So it is, it's a deception. And sometimes, the statistics and data and things are given to people using percentages to throw you off and be deceptive. So keep an eye out for that. Just make sure you work out those percentages and say, well, a 25% decrease and followed by a 32% increase does not mean you have more than what you started. You still have less. So, make sure that you follow up on some things like that. So that was kind of more of a tricky question, but one to kind of get you thinking before you take any quizzes and look for those deceptions. I mean, if they give calculations, carry through the calculations if you can, and if you can't, that might be another thing that they're deceiving you with, because if you don't have enough information to do the calculation, that might be one of the things that they're leaving out so that you can't do the calculation. So you have to take their word for it, which doesn't usually help. So for the next one. So now we're getting into the type of things that you were asked to do towards the end to find mean, median, mode, so forth and so on. So as we see here, we have a number of scores here. We have, let's see what we have here. And it's always good to kind of start summarizing the information that you have in front of you. So when I look here, I have, it looks like, let's see, 9, 18, 19, 20, 21, 22, 23, 24, 25. So I have 25 scores here. Might be a good idea for me to sum them up, and I would eventually, for sure. And then, but like some of these questions here, like the median, the modes, anything else that's asked for here beyond that? No, it's just a good standard deviation. The median and mode, it would probably be a good idea for me to have this information in order. And certainly to find the mean and start working towards standard deviation might be a good idea for me to have them in order and actually have them added up as well. So I'm going to perform some of those calculations at this point. I almost forgot about that 66 there. so, um, so we have them listed in order now, and I did sum them up to be 1,878. So if I wanted to figure out what the mean was, I would take 1,878, the sum of the totals, over 25, and that would equal 75.12. So that's what that is. With them written in order now, I can now figure out what the median is. So if I did 25 over 2, I get 12.5, and so I round up to the nearest, which would be 13. So the 13th position in the ordered list should be the median. So I'd count off 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. And so the median should be 76. The mode, well, the mode, I'm just looking for the most frequent score. I mean, I see 88 appears twice, 84 appears twice, 81 appears twice, 72 appears 3 times, but so does 76. And since those two appear the most frequently, and they're tied at 3 apiece, those are the two modes. So 72 and 76 are the two modes. And I think you were asked to list them in order as far as from lowest to lower, the smaller to bigger. So that's the order you should definitely be listing them in. But they told you to list them in any order whatsoever. So there's different ways you could have listed them. 72, 76, 76, 72. You weren't restricted on this one. So now standard deviation is always a much more involved calculation. Now I have all this information here. I have the mean right here. What I have to do is start coming up with, the data. And so what I have to do is then figure out, okay, if all this data, I'm going to have to do each score minus the mean squared. Now, one's like 72, I just multiply that by 3. But I got to come up with that and get their sum. And so I would have to do 44 minus 75.12 and square that. 50 minus 75.12 and square that. 55 minus 75.12 and square that. So forth and so on for each piece of data. For like 72, I could do 3 times 72 minus 75.12 squared, and so forth and so on. And so, if I go through and make sure to do that, what I get is the following. So again, if I take each one of those scores, subtract the mean from it, square it, then add them all together, I get a grand total of 3422.64. And so if I have that sum over 1 minus n, or n minus 1 I should say, so that's going to be over 24, that would give me my standard deviation. And that ends up being 11.94 approximately. For the last question you're given very similar types of data. Except now it's written as a stem and leaf plot. So make sure you do know how to read all the different plots. I mean, here I gave you a stem and leaf plot, but make sure you know how to read like a box plot. Make sure you know how to read histograms. Make sure you know how to read pie charts, or circle graphs is what they call them. All of those so that you can find the data needed to answer the questions given. So, as you do a stem and leaf plot, again, you have to kind of keep in mind that as you go through the data, so the data in the first line is basically saying there's 48, 48, and 49. So writing that a little backwards there. And the second line, of course, is 50, 52, 52, 53, 55, 56, 56, and 57, so forth and so on down the line. So you have to be able to read the data from the stem and leaf plot so you could come up with this information. What's nice about it is if it's written in a stem and leaf plot, it is written in order. It's going from lowest 48 up to highest 72. I can count how many pieces of data there are. So I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I know n's 25. And I can figure out the sum of the data just by adding all those numbers together. And so with that, I can find the mean. The median, mode, Q1 and Q3 are also pretty easy to find because it is ordered data. Again, the standard deviation is what's going to cause most of the difficulty. Mostly because of the fact that I have to take each one of these scores, subtract away the mean, square it, add them all together, and then divide by 24 and then square root it. So there's a lot of things that go on with the standard deviation. So let's kind of walk through some of these and let me come up with the answers to these. So let's get that sum together. So if I take all the scores, 48, 48, 49, 50, 52, so forth and so on, add them all together, I get a grand total of 1,488. And so now, if I take that 1,488 and divide it by 25, I get 59.92. I'm going to work on the standard deviation now because the rest of it's on the easy side. So I had that 59.92, so I got to take each one of these x's. These scores would be my x's. I got to take each one of them, minus the mean, square them, and then add them together. That's what this symbol means. So if I did that, I get 1,404.24 approximately, and therefore the standard deviation would be the square root of that over 24, which is, n, which is 25 minus 1. And if I square rooted that, I get approximately 7.65. It's like 64918, so forth and so on. So that's about the standard deviation. The rest comes from me having an ordered list that are very helpful for it. So the median, again, since I'm looking for the halfway point. So if I take 25 divided by 2, I get 12 and a half. Rounded up to 13. The 13th term would be my median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, it's 13th, I should say. So right here is where my median is. So my median looks like it's going to be 60. The mode, let's go down here. The mode's the most frequent score. And like I see, I do have some scores that appear twice. Like this one appears twice, this one appears twice, this one appears twice. But this one here appears 3 times, and that corresponds to having 3 61s. So the mode happens to be 61. Now, these numbers here represent the first half, and so Q1 should be the median of that. So there's 12 terms in there. If I take 12 divided by 2, I get 6. And 6, you know, the 6th and 7th term are what I'd be looking for as my median, as my Q1. So 1, 2, 3, 4, 5, 6, 7. So 6th and 7th terms. So basically here, Q1 should be the average of 51 or 52 and 53, which would give me 52.5. On the same token, Q3, let's see if I can find another color here. We'll go with orange. Q3 would be coming from the numbers in this region, these 12 numbers. It should be the halfway point of that. So it should be the 6th or 7th term in that group. So 1, 2, 3, 4, 5, 6, 7. So Q3 should be 64 plus 66 over 2, which would come out to be 65. And that's how you come up with these values. So, and that's the last question you had on your practice quiz. If you have any further questions, please make sure to reach out to me. Until next time, though, have a good day.